In recent years, an Indian community in Chile has found a way to use free electricity. Since then, not only do they not have to pay for electricity, they can also sell electricity back to the grid to earn a substantial profit. So where do these power sources come from? This is because there is a small river flowing through their settlement. A group of people from Leuven, Belgium, has taken notice of this place. They plan to conduct an experiment here. The purpose is to demonstrate that, as long as there is river water, it can generate green energy, self-sufficient. They added a channel, bending into the river, to straighten the original river flow. Must be bent here. Why must it be bent? Because the river is straight, has a steady flow rate. Bending will cause an increase in flow speed. In order to install turbine blades, achieve the goal, generate free electricity. Previously, hydropower has always been an extremely large project, like the gigantic Three Gorges Dam of China, is a massive power plant with a capacity exceeding 100 billion kilowatt hours. The principle of hydropower generation. The principle of hydropower generation is to use the height difference of the water flow, then combined with water turbine generating equipment to generate electricity, converting mechanical energy of the water turbine into electrical energy through the generator, then transformed into electrical power. Its cost is very low, and it does not cause pollution. There have been many achievements around the world. Furthermore, hydropower generation is about bringing water from high places to low places. Water in low places will evaporate under the sunlight, then circulates everywhere, forming clouds. Is a perfect closed loop. Based on the same principle, the turbine generator here also uses the height difference. At hydroelectric power plants are all super strong flowing waters. Then ordinary small rivers can really generate electricity. In inhabited areas, the river's flow rate will not be too fast. Height difference will also not be too large. So how to generate electricity efficiently? This group of people in Belgium has keenly discovered the slow flow rate is due to the distance being too long. If the distance is shortened, the flow rate, can it be increased? Based on these details, they added a curved channel in the middle of the river, initially requiring 100 meters of flow from high to low, now has been shortened to just a few meters. These curved systems will create a height difference of over 1 meter. Water flowing in from above will form a whirlpool. The whirlpool then will make the rotor start to move, proceed to draw in air through the generator, converting it into electrical energy. When there is electricity, how to mass produce and transport? The accompanying equipment can receive power sent through a transformer, transmitted to the residents' homes. A turbine generator, this small, is certainly still not enough to provide electricity for the entire village. Therefore, it is necessary to install many turbine generators on the river. Divide the river next to the village into sections to install the generators, and the winding canals reconnect with each other to create a power generation module. The smallest model is a 5 kilowatt turbine. Larger ones also include 15 kilowatt and 300 kilowatt. For larger rivers, there are also megawatt turbines. That can provide electricity at a minimum for 60 households continuously for 24 hours. Is that really the case? So during use, there won't be any issues, right? Of course, there will be issues, because this is a water channel. Therefore, it cannot be avoided. The presence of debris, branches, or fish. And if it gets blocked, what should be done? Actually, in this matter, there is no need to worry at all. First, each bend has a protective net, which can ensure that nothing falls from the sky. Second, at the entrance below, has also been installed a protective mesh, and fish can still move freely, and is designed with a slow rotation speed, and curved blades help aquatic organisms remain unharmed, prevent damage from external impacts. Primarily is the natural wear of equipment. It has an energy consumption of at least 400 kilowatts per year. High durability turbines have low maintenance costs and are less affected by external factors, can provide stability during operation, sustainable return on investment, very suitable for schools in remote areas, including hospitals, including hospitals and basic public infrastructure. It is completely emission-free and extremely environmentally friendly, also completely suitable with future development trends. Has been present in Belgium, Chile, Portugal, France. In places like Indonesia, has also been implemented. Nowadays, everyone focuses on cleanliness and greenery, sustainable development. The automotive sector is also moving towards green development, and electricity is also becoming more diverse. Solar energy, wind and water are infinite resources that are never exhausted, because the principle of hydropower is the difference in elevation. When hydropower is available, it is not entirely just the riverbed. As long as there is a place to create a height difference, it is all possible to install turbines for electricity generation. This year, this group installed for the first time in France, at the water treatment plant, Versailles, Suez province, in Suez, added a 5 kilowatt turbine. Wastewater that originally needed treatment suddenly became a valuable resource. Truly, if you have intelligence, along with creativity, you can definitely turn useless things into extremely useful things.